Hello everyone, welcome to the OneClass channel. My name is Millan and I am a software engineering student at Carleton University in Ottawa, Canada. Today, I will be going over some commonly asked mathematics questions at the high school level, and if you're interested in getting some homework help or if you're interested in getting some tutoring, check out the links in the description below. Cool, so we can get into some mathematic magic in a way that we can do it the fastest. So let me do it, let me switch up my screen ASAP fast like this. Okay, we should be good, so we can get magic with the mathematics. Okay, so the first question that we got on the menu today is asking us, what is 16 divided by 3? Now there are many ways that we can write this. We could write this as 16 divide 3. We could also write this as a fraction, 16 over 3. Now I think it's better to kind of think about it in a more fractional sense because fractions are very commonly used, especially as you get deeper into the world of mathematics. So let's think about what this fraction means. This means if we have, if each piece, or if it takes 3, if it takes 3 to make 1, how many will 16 make? It's pretty much what this is saying. Or if we're trying to like equate this into like a math question, into like a physical word type question. Okay, so 16 times divided by 3. I want to think about it. Okay, how many times could we fit 3 into 16? So let's try counting this together. So we have 3. Okay, then we have 6. So this would be 1 times 3. Equals 3. 2 times 3 equals 6. Okay, we're getting closer. What about 3 times 3? We know that that's going to be 9. Not quite there yet. 3 times 4. 12. Are we there yet? Not quite. Let's try again. 3 times 5. That's 15. Okay, we're really close. But if we were to do something like 3 times 6, it's 18. A little too much there. We know that it has to be 16 over 3, somewhere between 5 and 6. Okay, so yeah, so we know that it's going to be between 5 and 6, but this, I think 5 is a little bit closer. 15 is closer to 16 than 18 is. So if we do 5, we're going to have 15, but we're still going to have 1/3 left, right? Because we have 16 thirds. If we have 15 thirds, that makes 5, but we're still going to have 1/3 left. So 15 and 1/3. Now let's try to convert 1/3 into a decimal form. What's 1/3 as a decimal? Well, 0.333. So another way of writing this is equal to 5 plus 1/3, which is equal to 5 plus 0.333 with a line on top. And that line on top means that we got a whole lot of 3s, an infinitely large number of 3s. You don't want to write all the 3s. That will take, you know, your whole life and then some more. So instead we can just write a line on top of the 3s, and that means that it's repeating. So of course this seems like fairly straightforward math, so we know that the result of this is going to be 5.333 with a line on top, and this will be equal to our original question, which was what is 16 divided by 3? 16 over 3. And another way of saying that, what is 16 divide symbol 3? Now you got to be very familiar with the divider operation. As well as fractions. It might be a little bit intimidating at first, but once you get the hang of it, you'll really see that they are very useful. They're both completely valid ways of representing it. Fractions are typically preferred as you get deeper into your mathematic knowledge, but yeah, just stay ready to handle both of them. So the above solution is good. Of course, you could just send this into your calculator and you can get the answer like ASAP fast, but you know, sometimes it's nice to think about these things in a more abstract sense. Okay, cool. Okay, so the next question that we have on the menu today is asking us, how could we possibly simplify the square root of 20? Okay, let's write that out. Simplify the square root of 20. Root 20. Okay, now let me tell you about this rule about simplifying rational numbers, or for simplifying not rational numbers, simplifying things that are under the square root. Okay, so general rule or general procedure for simplifying roots. So the first thing that you want to do is you want to factor your radicand. You want to simplify the under the root number until as many terms as possible. So simplify the under root number into as many factors as possible. If you see a repeat factor, bring it outside. If you see a repeat factor, bring it outside the root. Okay, cool. So let's apply this general procedure to our current situation. So our current situation is we got 20 underneath the square root. Okay, so here we got our 20, and then we want to factor 20 into as many terms as possible. Okay, let's think about what can we multiply together to get to 20. We can do 1 times 20, but that's not really helpful because, well, you can multiply 1 as many times under the root, but it's not really going to change anything. So don't worry about multiplying by 1. Now let's think about how else can we get to 20. We could do 2 times 10. Yep, that sounds about reasonable. Okay, so we know that 20 is equal to 2 times 10. Okay, but we want to still keep trying to factor these things down into their as simplest terms possible. So what do we know about 10? How can we possibly get to 10? Well, I know 10, 5 times 2, 5 plus 5. Bro, that's got to be 10. So we can rewrite this as 2 times 2 times 5, right? 2 times 5, that's got to be 10. And, multiply that whole thing by 2 again, and you'll get 20. So we can put this whole thing under the root, 2 times 2 times 5. Let's put that under the root. Okay. Put under root. And this is completely equivalent to what we had before. So before we had 20 under the root. Now we have 2 times 2 times 5 under the root. Okay. So the next thing that was a part of our general procedure for simplifying roots is if we see a repeat factor, we can bring it right outside. Okay, so if we look at our current situation, we have, oh my goodness, would you look at that? 2 appears twice. So we have 2 2s. We got 2 2s dressed up under this root, dressed up in a tutu. Ha, very funny. Okay, so we can bring this outside. And bring outside of root. Okay, now what we really mean by bringing this outside of the root is that those two together, because we have a square root, anything that's multiplied by itself, when it leaves the root, just becomes itself. Okay, so in the root, or when it's brought out of the root, it will become 2 times root 5. Well, that kind of looks like a 6. Let me draw it as a 5. Okay, so when you find twins under the root, you're leaving, one of the twins is going to disappear when you bring it outside. Okay, so that's That's a nice way to think about it. So bring outside of the root. One twin is lost. Is lost. And this will be our final answer. 2 times root 5. And when we look at the 5, the number under the root, could we simplify that? Can we factor out 5? Not really, because 5 is a prime number. Can't factor prime numbers into anything smaller, so we can just leave it at this, okay? And I mean, another way that you can think about it is try to see if you have perfect squares. But in my opinion, this sometimes it's hard to recognize perfect squares. Especially as the numbers get really, really big. So this procedure in general, I would recommend, because you keep factoring everything until you get to like purely prime numbers, and then anytime you see a twin, bring it outside, but it becomes a single child once it leaves the root. Twins under the root becomes single children outside of the root. Okay, cool. So that would be the solution that we give, and things look good. Awesome. So the above solution is good. Okay, so the next question that we got on the menu today is asking us, how do we write x to the power of 2 over 3? I'll write that more a little bit larger, because I imagine that could be a little bit difficult to see. 2 over 3 x to the power of 2/3 in radical form. Radical form. Okay, now what is radical form? Radical form is when you have radical form looks like this. So what we're going to expect is maybe some number here. We don't know what it is yet. Let's just call that n. This will be like a general radical form. And then we'll have maybe like x under here, or maybe not. I won't use x because we're already using x for this. Maybe we'll say a. So we're going to have something under a root, and the n is to specify which root. So if we have a square root, we're typically not going to write 2 here, because square roots are so common. We just draw like the root thing, and we leave it at that. But let's say you're doing a cubic root, which is saying like who multiplies itself by itself thrice to become this, and you would have like a 3 there. Okay, but this is what we're looking for in the end. We're trying to get something like this, and a nice way to think about this is, another way we can write this is a to the power of 1 over n. So anytime you have a 1 divided by a number as the power, that can easily be turned into a radical. Okay, so let's see what we can do here. Well, we don't have a 1 on top of here, but we do know that here's an interesting rule about exponents. So here's an exponent rule. Our exponent rule is that, let's say we have y, and I'm just using y as like a generic variable, but you could use y, x, w, square, happy face. You could use whatever you want to use, whatever symbol you like, as long as it's clear and obvious to you what it represents. Okay, so use your creativity if you'd like. So let's say we have y is of m times n. Another way that we can write this is y to the m times n. Okay, now we want to apply that principle here, because we know that 2 over 3, we could rewrite this as 2 times 1 over 3, right? And then we have exactly what we want here, like we have a fraction with 1 on the upstairs, 1 in the numerator, the 1/3, and then the multiply by 2, well, we can keep that under the root of the radical form, so we can deal with that appropriately. Cool. So let's say we can rewrite x to the power of 2/3. Another way we can rewrite this as x squared multiply to the power of 1/3. Right? And you can see with this rule, it would be perfectly equal. They have to be perfectly equal. I know for a fact they are perfectly equal. If I'm lying, I'm flying. Okay, so, and then we want to use our other rule. Wait, what was our other rule again? When we have 1 divided by a number as the exponent, we can turn it into a radical that looks like this, with the number that's on the denominator as the, what is the n in the radical form equation that I drew out here. Cool, so let's actually do that conversion right now. So in this case, our denominator is a 3, right? So we're going to have the cubic root. And what's underneath the root? Well, whatever inside here, and we have x squared. Okay, and that will be our final answer. In radical form, x to the power of 2/3 is equal to the cubic root of x squared. There are many different reasons why you may want to go between these. Honestly, it's typically more useful, like the deeper you go into your academic life, it'll typically be more useful to have it in as a fraction instead of as a radical, but you got to be familiar and comfortable with going either direction, radical to fraction, fraction to radical. Either way should not be too intimidating. It should be nice and comfortable. Sounds good? Cool. So yeah, here we have the above solution is good. Awesome. Okay, so the next question that we have on the menu today is asking us, solve logarithm base 2 of 256 is equal to x. Okay, so let's write this a little bit bigger here. Log base 2 of 256 is equal to x. Another way that we can kind of think about what this really means, because sometimes it's difficult to think about logarithms, is 2 to the power of something, 2 to the power of x is going to give us 256. And we're just basically trying to figure out how many times does 2 multiply by itself to get up to 256. Okay, so let's actually we do like a step-by-step procedure to kind of figure this out. So, if we have 2, well, that's just going to be 2. What about 2 times 2? That's going to be 4. Not quite there yet. What if we multiply that by 2? That's going to be 8. Still not quite there yet. If we do another times 2, this is going to be 16. Not quite there yet. Times 2. This is going to be 32. Not quite. Times 2. Well, this will give us 64. Times 2. This will give us 128. Times 2. And this will give us 256. And that's exactly what we're looking for, 256. So now we want to count how many times we multiply 2 by itself. So we have 2 is multiplied by itself. So this be 2 squared. Okay, so 2 squared. This is 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, 2 to the 7, 2 to the 8. Okay, so we know another way that we can write this is log base 2 of 2 to the power of 8 is equal to x. And another way that we could write this, because to follow the similar format as the first one that we wrote here, is that 2 to the power of x is equal to 2 to the power of 8. So what does x have to be? Well, for those to be equal, x has to be 8. There is no other way that we can put this together unless x is somehow equal to 8. Okay, so that gives us the result of this. Logarithm base 2 of 256, we gotta be 8. Okay, and yeah, so you can kind of see here, like we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8. The number 2 appears 8 times, so it's got to be 2 to the power of 8. Okay, hopefully that makes things clear, and that we can call that a solution done. So solution is good. Okay, so the next question that we got on the menu today is asking us express the following expression as a single logarithm and then simplify it. Okay, so this is what we're starting off with. We're starting off with logarithm base 2 of 128 minus the log base 2 of 2. Let's put these in brackets so that we're kind of clear on that they're related to each other. And we're going to try to simplify these, okay? Now, let me tell you a little law of logarithms. Log laws. That's a fun thing to say out loud many times. So we know that log base b of a minus log base b of c, because I don't want to use b again, this is going to be equal to log base b of a divide c. So whoever is being subtracted is going on the downstairs of that. And another thing that's like kind of related to this is log base b of a plus log base b of c is equal to log base b of a times c. Okay, and these are really the same law. It's just kind of goes to show like when you have addition or subtraction, like it really is kind of the same thing going on, but you know, the signs kind of determine if it's going on the upstairs of the fraction or the downstairs of the fraction. Now in this case we have a subtraction situation, so if we want to simplify this down, we're going to be using this rule, and those two situations are going to come together to give us this. So log base 2 of 128, and they have to be the same bases here. You see how b is the same for all those log laws stuff? If they're different bases, this ain't gonna work out. So it have to be the same base. So log base 2 128 minus log base 2 of 2 is equal to log base 2 of 128 divided by 2. Nice and straightforward. Okay, now let's simplify that a little bit farther. So that's log base 2. Now what's 128 divided by 2? Well, the quick mathers of us could see that that is got to be 64. Just 64. Okay, and we're trying to solve for what in the world that is going to possibly be. So basically what we're trying to figure out is 2 to the power of something is equal to 64. How many times is 2 going to multiply by itself to get to 64? Okay, let's we could ask our calculator this, and our calculator could tell us very quickly, but we can also do it by hand just by thinking about it, because 64 is a fairly low number. I feel like we can get there. So if we just start with 2, that's going to be, you know, 2 to the power of 2, that's going to be 4, and that's not quite there. 2 to the power of 3 is going to be 8. Hey, wait a minute. 8 times 8 is equal to 8 squared, which is equal to 64. It's almost like we kind of found a shortcut. So if we know that 8 times 8 is 64, and we know that 2 to the power of 3 is 8, we could also write that as 2 to the power of 3 times 2 to the power of 3 is equal to 64. Because we know that 2 to the power of 3 has got to be 8, so these have to be the true. And what we know about this is that we could rewrite this as 2 to the power of 6, because anything, the rule is this. So the base to the power of m multiplied by the base to the power of n, and these are just like I guess general variables. You can sub in whatever number as long as like the b's match. The m and n don't need to match, but this will just be b of m plus n, right? So that's why that works out. So it would seem that this is equal to 2 to the power of 6. So the result, x must be 6. So the result of log base 2, 128, minus log base 2 of 2, this has got to be 6. Okay, fairly straightforward. Ain't this fun? The log laws are always a great time and very useful across many different academic areas. So yeah, the above solution is good. But if you're on a test and you're tight for time, definitely put this into your calculator. Don't try to like manually figure out how many times something multiplies by itself to get to your result. Calculators are pretty helpful. Can't lie. Cool. So yeah. Okay. So the next question that we got on the menu today is asking us, find all of the solutions over the 0 to 2 pi, which is pretty much just like everything within one rotation. Find all those solutions. And we're basically trying to solve for x. And we know that sine, the question that we have right here is sine 2x is equal to root 3 over 2. Okay, so what do we actually know about what has to be going on here? So this, we know that sine is going to be this is going to be like the opposite over hypotenuse. And root 3 over 2 should hopefully ring some bells, but I'll draw some stuff out to hopefully make the stuff more clear. Okay, so suppose we have a right angle triangle like this. Okay, and then suppose we have a vertical line going right down the middle, just like that. Okay, now maybe I'll switch up my colors. So imagine this side length is 2. This side length is 1, but there's also this side length which is 1. Like you could see it was originally 2, but since we chopped it in half, they're going to be 1 on each side. This is an equilateral triangle. So we know that this got to be 60 degrees, which is another way of saying that is pi over 3. And this is the same deal, 60 degrees. And over here, well, it's going to be 30 degrees here, which is pi over 6. And over here, also going to be 30 degrees, which is also going to be pi over 6. Just radians and degree conversions are really important. So hopefully, you know, you keep your mind right and recognize that you can go back and forth between them comfortably, because it is important. Okay, now let's try to figure out what the hypotenuse here is. No, not the hypotenuse, the height here, like this. So let's just call this h, and we know that 2 squared equals h squared plus 1 squared. Okay, so if we wanted to solve for h, well, we would subtract 1 squared from both sides. And well, let's first like you know, expand this out. So we have like 4 equals actually we can do that one step. So 4 minus 1 equals h squared. And so h must be the square root of 3. So this height is the square root of 3. And in which angle would it correspond to if we have the opposite as square root of 3 and the hypotenuse as 2? Well, we would need this angle right here, which is pi over 3. This would be the only way that we can correspond to that. So we know that this has to be sine pi over 3. Which means that since we know that sine pi over 3 is equal to sine 2x, we know that, well, we can get rid of the signs and we'll just have pi over 3 equals 2x, and we can divide both sides by 2 to get x on its own. So we'll have pi over 6 is equal to x. Okay, that's going to be like our base angle, but we have to think about this in the bigger picture, right? So let's imagine, let's draw out like some Cartesian grid like this. Okay, so here will be our y-axis. And here will be our x-axis. Okay, so we've already confirmed that pi over 6, this is confirmed because we know that sine of 2 times pi over 6 is equal to root 3 over 2. Okay, but we also got to think about angles that are possibly bigger than 180, angles that are possibly bigger than 90, angles that are possibly bigger than 270. That could also lead to a answer that corresponds to this, right? So let me introduce you to something called the cast rule. So if you write out cast like here, the first letter corresponds to who's going to be positive in these quadrants. So here, there's going to be all positive. Here, we're going to have sine positive, but tan and cos will be negative. Here, we'll have tan positive. And here, we'll have cos positive. Now, we already know that since we're working with sine, these two downstairs are disqualified. Disqualified, need positive sine value result. Otherwise, the result of doing a sine is going to be a negative number, and clearly our answer that we are given is not a negative number. Okay, so we can't really have that. Okay, so we know that somewhere between 90 degrees and 180 degrees, we're going to find that sine times 2 times one of those angles is going to give us root 3 over 2. Okay, so let me let's think about this a little bit more. We want to think about what's going to give us root 3 over 2. And essentially, we're going to be looking for a situation like this, where we're going to have an angle like this. This is what's going to lead us to root 3 over 2. Because this is going to correspond to pi over 3. And because we want pi over 3 to ultimately be on the inside of the sine, right? Keep in mind the multiplied by 2 inside of the sine kind of complicates things by a little bit. Okay, so if this is what we want, that means that this angle here, this has got to be 2 pi over 3. Okay, so essentially what this means is that sine 2 pi over 3 is equal to root 3 over 2. Ask your calculator. Your calculator should definitely agree with that. And we know that this is equal to sine 2x. Well, if this is the case, I'll write it down here just to be a little bit clearer. Sine 2x is equal to sine 2 pi's over 3. Then we know that x has got to be pi over 3. It's got to be the case. Okay, so our first answer was pi over 6. Our second answer is going to be pi over 3. And we just need to know, like, it has to be, we're looking for the angle with respect to the x-axis. And we're always, like, in the quadrant here, we're going to go clockwise from the x-axis. In the quadrant here, we're going to go counterclockwise from the x-axis. So always make an angle measurement from the x-axis, and you want to make sure that your angles correspond to that. Okay, cool. So our two answers, our first answer is x equals pi over 3. Our second answer is x equals pi over 6. Both of these lead to situations where we can say that sine 2x is equal to root 3 over 2. Okay, typically there's always going to be two solutions for any trigonometric function like this, and a lot of the times you'll be asked to find all of the possible values between 0 and 2 pi, so just stay ready for that. Okay, so yeah, the above solution is good. Cool. So the next question that we have on the menu today is, given that we have log 3 of 4, or I'll just write these out because these will be important. It's kind of like we're drawing out a table here. So we have a lot of given values, and given those values, let's predict the value of log base 3 of 44. Now, using your calculator, that's way too easy. That's not going to be acceptable for this situation. So let's write out our givens. We know that log base 3, oops, kind of doesn't look like a 3 of 4 is equal to 1.262. Log base 3 of 7 is equal to 1.771. And log base 3 of 44 is equal, whoops, not, that's what we're looking for. We're actually, what we're given is log base 3 of 11, and this is going to be equal to 2.183. Awesome. Okay, now we're trying to find log base 3 of 44. Now, what do we know about 44? Maybe we could rewrite this as perhaps log base 3 of 4 times 11, because we know 4 times 11, that's 44. And, you know, do we have any special rules that we can deal with a situation like this? We know that when we have things multiplied together, exactly, here's a rule here. So I'll write out the general log rule. And the general log law, let's make this blue. We can have, let's say we have log base b of x plus log base b of y. The only thing that matters is that they have the same base. This will be the same as saying log base b of x times y. Okay, so given that, let's apply this rule to the situation that we have here. So this is equal to log base 3 of 4 plus log base 3 of 11. And we already, hey, weren't we given those? I sure think we have. So we have 1.262 for log base 3 of 4. And then we have plus 2.183. Yeah, okay, so that's whoa, that was not what I wanted to do. Okay, everything should hopefully be good now. Okay, so what we have here is log base 3 of 44 is going to be the result of the addition of 1.262 plus 2.183. Okay, so we have 5. 6 plus 8 is 14. Carry the 1, we'll have 4. And then no carries, so that's going to be 3. So 3.445. That's going to be the result, and that's precisely what we have calculated here. So yeah, the above solution is awesome, and good job. So log rules are great, and they're very useful in many applications. So solution is good. Okay, so the next question that we have on the menu today is asking us to solve for h in the following equation. So we have a is equal to 1/2 b h. Now, some of you may recognize this is the area of a triangle. And this can be quite useful. Let's say you're trying to solve for the height of a triangle and you only know its area and its base. And you're trying to solve for its height. Okay, so first thing that we want to do is multiply both sides by 2. By 2. So we'll have 2a is equal to 2 times 1/2 bh. And would you look at that? The 2 up here and the 2 down here, they neutralize each other. Okay, so what we're left with is just the bh equals 2a. And then we want to divide both sides by b. Sides by b. Okay, so we're going to have 2a over b is equal to bh over b. And we can see that the b on the top and the bottom, they neutralize each other. So we can rewrite this as h. So we know that h has to be 2a over b. And then we can say, good job to us, because we cracked the code. We isolated h, we solved for h, and we can be the coolest people around because we know how to get the h. Okay, so awesome. So the above solution here is good, and this is a fun time. Solution is good. Awesome. Okay, so the next question that we have on the menu today is asking us, how do we factor x squared plus 4? Factoring x squared plus 4. Okay, now the reality is this is going to be impossible to do unless we go into the complex number world, the imaginary number world, as some of you may have also heard of it. So now this has a very similar type of atmosphere as conjugates. So here we have our conjugate formula. Suppose we have like a squared minus b squared. This is the same as saying a plus b, a minus b. Because, well, if we cross multiply, we'll have a squared plus or minus ab plus ab minus b squared. And you can see that these middle terms neutralize each other, and we just get a squared minus b squared. And you can see how that all works out, right? So if we try to fit this into here, plus 4, well, we're missing the minus in the middle, so that's a little bit complicated, but we can kind of force that minus to exist if we do something like this, x squared minus 4, because we know that minus minus is going to be equal to the plus. Okay, so another way that we could write this is if we break it into its conjugates, we'll have x plus the square root of negative 4 and x minus the square root of negative 4. Okay, now I know it's very likely that you've heard something like, you can't take the square root of negative numbers. The answer, well, I hate to say it, but you actually can, because the square roots of negative 1 is equal to the imaginary number I. And I is just like a variable, and given this, we can do a lot of good things. So the square root of 4, of negative 4, we could rewrite this as the square root of negative 1 times 4. We could rewrite this as the square root of negative 1 times the square root of 4. Square root of 4, we know that's going to be 2, so we can have this as, and we know the square root of negative 1 is I, so we can have this as just 2i. Okay, so if we were to put these into our equation, this is equal to the square root of negative 4. Putting these back into our equation, we'll have this. x plus 2i, x minus 2i. Okay, now let's multiply them back together to see if this is a reasonable way to factor them together. Okay, so here to do the cross multiply, we'll have x squared plus 2, it's going to be minus, my bad, minus 2xi, and then plus 2xi, and then minus 2i, and that's all squared. So as before, you see that these two neutralize each other, and so here we're going to have x squared, and here, well, we're going to have minus, so 4 times I squared, which is equal to x squared, and keep in mind I squared is -1, so we can add another -1 term in here, minus 4 times -1, which is equal to x squared plus 4, because the negatives, double negative, neutralize each other into a positive. Okay, and we can see that we got exactly back to where we started. So this is the proper factorization here. But if you have not been introduced to complex numbers, and if you feel like you're not expected to know complex numbers, you could just say that this is impossible to factor, staying with only real numbers. Okay, so we have to go into the complex plane to solve this. So yeah. The above solution is good. The last line is missing a square on the I term. Okay, so the next question that we have on the menu today is asking us, which of the following is a quadratic function? Okay, so what are some clues that we want to look for in a quadratic function? In a quadratic function, well, these are the things that we're kind of looking for. Quadratic functions. We're looking for something like this. Okay, so first we're going to look for needs an x squared term. No terms have x to a power higher than 2. And that's pretty much just the criteria that we have. Okay, so let's look through our options here. So the first one, we have, this is option A, we have f of x, this is equal to 5 plus 9x squared minus 6x. Does this pass the test? Does it have an x squared term? It sure does right here. And none of the terms have x to a power higher than 2, so this is quadratic. Let's check out B. Does B follow the rule? Let's see what B is. So B, we have f of x is equal to -4x minus 2. Missing x squared term, unfortunately. So this can't be quadratic. So missing x squared, sad face, not quadratic. You can't be a quadratic quadricopter. So this is actually a linear function, so that's really just a line. What about option C? Option C, we got -5x cubed. That's a big red flag right there, but I'll write the whole thing out just to be complete. X squared minus 2x minus 3. But this is x3 makes cubic. Sad face, you're not a quadricopter. You're not a quadratic function, so it ain't gonna work out. And for option D, we got 2 minus 7x, and, well, missing x squared. sad face. You're not a quadratic person party. So this is, obviously it's just got to be A. A was the only option that passed the test, so that will be our final answer. Everyone else has things that will break the rules of the requirements of being a quadratic function. Okay, so here the above solution is good. Explicit mention of how it is required to have an x squared term would be better, instead of saying it with a not equals 0. Cool. Okay, so the next question that we have on the menu is a word question that we kind of need to translate into a mathematical model. And then once we have that, well, we can solve it and be happy. So the question is asking us, 6 less than 4 times a number is 22. Find the number. Well, we can say A is going to be the number. So 6 less. So it's going to be minus 6. Six less than 4 times a number. So 4a. Let's say a is our number because, I mean, the a is in italics here, so I feel like it'd be nice and fitting. 4 times a number is equal to 22. I don't know about you, but I'm feeling 22. So we gotta find the number. So let's do some quick algebra here. So let's subtract, or let's add 6 to both sides. So we're going to have 4a minus 6 plus 6 is equal to 22 plus 6. And you can see here that the plus 6, minus 6 plus 6, this gets zeroed. Okay, so we will just have 4a is equal to 22 plus 6, which is equal to 28. Now let's divide both sides by 4. Both sides by 4, and we will get this. So we'll have 1/4 of 4a is equal to 1/4, whoops, not 1/2, 1/4 of 28. Okay, and as you can see here, the 4 on the denominator and on the times 4, they neutralize each other, and we'll just have a on this side, and then 28 divided by 4, let's do some quick math. It's got to be 7. So we know that a has to be equal to 7. That is our number of interest. And yeah, it's got to be the case. It's got to be the case. So exactly. So what they see here is they also came to a conclusion that a, or the variable, they used x, we used a, but it doesn't really matter which one you use as long as you can keep it straight in your head. It's got to be 7. Got to be 7. So the above solution is good. Awesome. Oh man, that was all the mathematic magic. Time flies when you're having fun, as the old saying goes. Switch over my cam real fast. So those are all the questions that we have for today. If you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and ring the notification bell below. If you would like to submit your own questions, please visit the links that we have in the video's description. If you really like the video, remember to leave a like and a comment, and if you really like the video, share it with your friends. This has been Millan from OneClass, and I hope to see you again soon. Take care, and have a great time doing all of the mathematic magic.